Hi, I'm Oladayo, and I'll be presenting this paper from our group titled GridShift, a faster mode seeking algorithm for image segmentation and object tracking. To begin with, the popular mean shift algorithm is preferred above other clustering algorithms due to its non-parametric nature and very good clustering accuracy. However, it suffers from the drawback of high computational complexity. Although recent speed-up proposed in the mean shift plus paper shows that by using active grid cells to facilitate the calculation of the neighborhood points in the mean shift operation, a linear complexity can be achieved. However, from the following example, it is clear that although the accuracy of the MS++ algorithm is superior to other clustering algorithms in terms of image segmentation, it still has a very high runtime. However, the proposed GridShift algorithm, although having a very good image segmentation accuracy, performs this operation at a very record low runtime. In terms of object tracking, CamShift, which is based on the mean shift operation, also, as we can see in this example, fails to track the object due to low lighting and background that features the same colors as the target object. However, irrespective of all these environmental conditions, the GridShift algorithm is still able to track the object effectively. Since the GridShift algorithm makes use of the same grid cells as the MS++, which basically show the difference between our proposal and the proposals of the MS++. The MS++ algorithm updates the location of each data point, while in GridShift, we only update the centroid of each active grid cells. And the active grid cells are actually the grid cells that has one or more points resident in those grid cells. Also, the shifted location of all the data points associated with the same grid cells has the same value at any iteration in the mean shift plus algorithm. However, this is not the case with the proposed GridShift since we update the centroid in a sequential manner. And from these two major speed up, we show that the GridShift algorithm is faster than the mean shift plus algorithm theoretically. The basic implementation of the GridShift algorithm can be summarized using the figure on my right. And as you can see from the algorithm 1, first is that we have an hash table that contains the centroid and the resident data point of each of the grid cells. And each of these centroid and the data point, in other words, all the values of the hash table are being updated in each iteration until convergence is reached. Here we show the comparison of GridShift's algorithm with other state-of-the-art algorithm on real-world clustering dataset. And as you can see, in all instances, we have a superior ARI and a superior time in terms of the time it takes to cluster each of these data sets. In terms of image segmentation, we perform experiments based on the BSD 500 data set, which is a very common data set. And as you can see on my right, we show the runtime of GridShift plus compared to other algorithms in performing this segmentation on the data set. And on my left, you can see the adjusted rand index and the FM. And as you can see, in all the instances, GridShift wins actually more than the other algorithms. To demonstrate object tracking, we show the following examples where, as you can see, CamShift, which is based on mean shift, actually fails due to the color of the target matching the color of the environment. And this is the result of the algorithms compared with other state-of-the-art tracking algorithm based on the OTB 100 datasets. And as we can see, the GridShift actually wins all other algorithms from the different classes. To conclude, GridShift is 40 times faster than the MS++ algorithm, and also in terms of object tracking, GS is able to track objects successfully irrespective of the environmental conditions. Thank you for listening.